Hi, good evening. My name is Kevin Mays, and I work for Giant Machines, and we build HTML5 applications for the capital markets, and we're located right here in New York City. So let me start out by asking, does something like this look familiar to anybody here? OK, yeah, I was expecting like 75% of the hands to go up, but I got only 55.8%. So this is this is like an order ticket for a trade, right? You can buy, you can sell. We even have JPM. We have JP Morgan here, so we're going to go along on JP Morgan after Andrew's great talk. So something is missing here, though. And I don't know that it's so obvious just from looking at the design. So in my experience, what's missing is the implicit underlying complexity that goes into building one of these. For example, what happens when the user submits the order to the server? And let's say that everything goes successfully. Well, then what does the user see? Now, things could also fail. So what about that case? Can the user try again? So even simple-looking UIs sometimes have use cases that are unaccounted for. They often require more designs. And the same hidden complexity can breed the same bugs again and again. Now, for the developers in the room, I'm going to guess that this may look uncomfortably familiar. In order to manage UI state, we often resort to using all kinds of Boolean flags to determine what kind of content are we supposed to render, and what kind of context do we need to be aware of when, let's say, a user clicks on a button. Now, incrementally layering on complexity, or building code from the bottom up, as it's called, is very risky. And it's difficult to understand, hard to modify, and even harder to test. Now, as an application grows, adding new features are likely going to become a problem. And we really need a solution that's going to enable us to keep up with an evolving product vision. Now, I've heard a lot about finite state machines and state charts for building UIs for about a year now. And I was really curious to try it out in an actual application. Now, finite state machines, which have been used in hardware and software applications for decades, consist of a known number of states, and the machine can only exist in one of those states at any given time. State charts, introduced in 1987 by David Harel, are an extension to finite state machines, one that's robust enough for UI development because of its formalized state chart notation and additional features. So we'll get into some of those features later. But for now, our order ticket can already benefit from state charts because it encourages us to define the states of our application ahead of time and also to define the transition between those states. One popular library that implements state chart features in JavaScript is called XState, created by David Khorshid, who's already given many great talks on this subject. Now, XState uses a JavaScript object to represent states and transitions, and it also provides a method for transitioning between those states. And it implements some of those other state chart features. So here we see the 4 states of our design. We have the form, ascending, success, and failure. Now, we do need to define an initial state so that the machine knows exactly which state to enter by default. In this case, it's the form. We also define the only transitions that are possible in each state and the states that they can lead to. We can add state chart features like actions when entering a state. So for example, when we want to post order data to the server, we can define a post order function that we'll work on later. So now, XState can be used on any JavaScript project, but many of the applications that I build are built using React. And in that case, I can use a library like React Automata, created by Michele Bertoli. And React Automata basically is built on top of XState, but is specifically for React. And it allows us to wrap an order ticket component like this, for example, using a with state machine higher order component, to which we also pass that same state chart object that we just saw previously. Now let's work on the content to be rendered by the order ticket, in particular the order form. So we can wrap this order form in a new state component, which is provided by React Automata. We can also add multiple state components, similar to how we might add multiple route components when using libraries like React Router. Now, for us to be able to transition to other states, we can add a click handler here to the order form component that allows us to call a transition function, passing in the ID of a specific transition. This transition function is a property that's passed to us by the with state machine higher order component. Now, do you remember that onEntry action that we defined in the state chart? Well, we can define this post order function right here in our order ticket, calling an API method and receiving back a promise. And then we can use that same transition function to handle success or failure and change states passing relevant data, for example, the response or the error object. OK, so far so good, right? Now we have a working order ticket that passes right through the sending state onto a success state or maybe a failure state. I think we're done. But what happens when the product manager comes in and says, hey, folks, we need to add a new feature? So instead of having the users just send the form right away, we actually want them to see this other screen where they can review the order, and then they can decide, do they really want to place the order, or do they want to go back and modify it? So this kind of breaks up our code and breaks up our workflow, and it sounds like we're going to have to add code, maybe modify existing code, and this is always risky. So it's times like this where I really wish that adding this new screen feature were about as easy as just inserting a new slide into this presentation. Well, actually, it might be just about that easy. So let's return to that state chart object, specifically the part where we defined our states. So currently, while in the form state, we have this submit transition that takes us to our sending state. Well, what if we could just add this new confirmation state right here along with the rest? Now, we would need to reroute that submit transition to lead to the new confirmation state. And then in the confirmation state, we could add a new send transition that then takes us to the sending state. So finally, in the confirmation state, we can allow the users to go back to the form and modify it. Now, depending on the complexity of the form, here's where we might use some of the additional state chart features like nested state or parallel states or even state history to return the user to the form exactly as they last left it. Do you recall that diagram we saw earlier? So diagrams very similar to these can be automatically generated from the same state chart object using a cool visualization tool located at the xstate repo. So now we can see that the same diagram reflects the addition of our confirmation state right in the middle there. The state chart object is always perfectly in sync with the actual code being executed in the application. Furthermore, we now have an effective communication tool that can be understood by product managers, designers, developers, and QA engineers, and this is significantly better than any natural language spec that we would normally have to draft and then maintain. And as a bonus, unit tests can be automatically generated from that state chart object as well, so we can test all of the paths between states via their transitions. Now, here we are back in the render method of our order ticket. We just need to add a new state component that contains our confirmation state. Now, I want to point out here that in terms of visual design, this confirmation state can appear as a modal dialog on top of the form or completely on its own, and none of that is dictated in any way by use of state charts or this state component. In fact, we can render any content we want to within this tag and style it however we wish. So, and finally, to complete this enhancement, we just need to pass in our two callbacks to transition to the sending of the form or to modify it. So what I've shown here in just a few minutes only scratches the surface of what state charts can offer us in the process of creating great UIs. But I really hope that I've been able to show you how adding a new feature is relatively easy and may not even involve any new logic or JavaScript code. All of the existing states and transitions are unaffected, so we shouldn't have any unexpected regressions. And now we can really welcome the addition of new features with far greater confidence. So to learn more about state charts, I highly recommend visiting statecharts.github.io, which is an excellent resource. And you can also read this cool book, Constructing the User Interface with State Charts by Ian Horrocks. And lastly, I'd like to invite you all to the Giant Machines booth over there, where you can see a demonstration of our trading app that was built using state charts. So remember, buying and trading stocks is still totally risky, but at least the creation of trading UIs just got a bit safer now. Thank you.